Welcome everyone. My name is Natan Silnitsky and I'm a backend infrastructure developer at Wix.com. And this talk is about the key lessons that we have learned over the years as we scaled up our Kafka-based distributed system to more than 1,000 Scala microservices. And you learn about the best practices, tools, and SDKs that we have created in order to achieve this. So a few numbers about Wix. We have 190 million registered users, more or less, from 190 countries. 5% of all internet websites run on Wix. And we handle more than 500 billion HTTP requests per day and serve 6 petabytes of static content. Now, our Kafka messaging as a bit lower scale, with 1.5 billion messages per day, but this scale is quite large for our inter-microservice communication, and we also have other scaling concerns. So we have all in all 1,500 microservices, 1,000 of them Scala-based, and 900 developers with all kinds of use cases that we as an infrastructure team at Wix need to support. So what do you do when the traffic, metadata, and amount of developers and use cases keeps growing? So the first lesson for this talk is about the need to have a common infrastructure with common features for this massive amount of developers and use cases. So all of you are probably familiar with the Kafka producer and Kafka consumer that are provided in order to communicate with the Kafka broker. So we decided to wrap that for our developers at Wix. And we did a wrapper called Greyhound, which basically has a simpler API than a Kafka SDK. And we added all kinds of additional features that help our developers achieve what they need to do. And Greyhound also serves an abstraction layer. So it will be really easy for doing changes like upgrading Kafka version or fixing a bug or introducing something new, and easily spread it to all of our services in production very easily. And we recently rewrote Greyhound on top of the Zio concurrency library, which was great fun. And we also have a Java API on top of it. So Scala future-based API, Zio-based API, and Java API. And let's see a few of the features that Greyhound offers our developers. So first thing is, if you look at how you set up a Kafka consumer, it's Java-based. So you start off and create a consumer. You need to specify the broker locations, and you have the key type and value type of each record. So you need to specify the deserializers for them, and quite a lot of other boilerplate. And when you actually want to consume messages, then you call the poll method from the consumer, and you get back records. And then you probably do some processing for each of these records, and you call poll and process and commit method again in a recursive style in Scala, probably. And if you don't want to lose any messages, then you'll probably want to commit the message explicitly after you process it, because otherwise, if you go with the default Kafka consumer of auto commit, you may end up losing messages in certain rare cases, but that could happen. So quite a lot of boilerplate here. And if you look at how we do it with our Greyhound API, so the user needs to specify a record handler, which basically just needs to get a lambda with processing of each record, and also specify the key and value types. And they will be automatically provided because usually you just want some JSON, or in our case, JSON or protobuf deserialization. And then you just provide the handler to the consumer builder with the topic and group, and that's it. And you don't need to explicitly commit the records or something like that. Greyhound handles it for you. You don't need to specify broker location. That will be injected automatically through the configuration file in production. Okay, so a very important feature that Greyhound adds that Kafka SDK lacks is parallel consumption. So if we go back to the vanilla Kafka consumer usage, then we do the polling of the records, but actually we can't do any multi-threaded access to the consumer. We can't just, if you want to have more parallel work, do more polling and processing like that. Because the consumer is not thread safe. So with Greyhound, what Greyhound does when it polls Kafka, it actually takes all the messages and then assign each of them to its own queue. All the messages from the same partition will be assigned to the same queue and processed in parallel from that queue using ZIO fibers. So fibers are, you can think of them as green, lightweight threads or green threads, where it's really cheap to do context switching between them, and they take up a lot less memory resources than JVM threads. So it means that we have very efficient parallel consumption out of the box for our users. And we also have Greyhound handling errors. So we have a distributed system. It's really important to make sure that even if an error occurs during processing, eventually the microservice will be able to recover and continue on. So Greyhound offers retries. We have here a non-blocking flavor of a retry configuration for Greyhound, where we specify I want to retry after 1 second, and then if that fails after 10 minutes. Of course, there can also be, there is also a flavor exponential backoff. You just provide a retry config to the builder, and that's it. You have it. And how does it work behind the scenes? So if the Greyhound consumer the handler fails to process the current message, there's a built-in retry producer that will produce the message to a retry topic. And there's a retry topic created for each of the intervals that you will set in the retry configuration. So retry 0 will process the message once the interval elapses. And if there's a failure then, it will then be produced to the second retry topic, etc. And working with retries using retry topics was inspired by an Uber blog post that we read and we implemented on our side. But there's an issue with retry topics that will cause your clusters to grow faster. As you see, we have a lot of retry topics potentially because users want to have many retry attempts. And so this kind of exponentially increases the amount of topics and partitions that we have on our cluster. So one way to mitigate it is to just specify by default one partition for this retry topic, and then you will have less increase in the metadata that your Kafka brokers need to handle. And we saw that with retry topics of the non-blocking kind, messages will be produced by retry topics, and at the same time, they will be also processed on the original topic. So you get out of order execution. But we do have a solution for that with Greyhound, where we offer a blocking policy where messages will be retried, the same message will be retried again and again until successful processing. But what happens here now is that you get a lag between the producer that keeps producing messages and the consumer that is stuck on the same one. So for that, we have a dashboard automatically created for each service where you have the ability as a user, once you get an alert that the lag is increasing, to go check out the payload and decide. If this payload is really not interesting and you can allow to skip it, you just unblock it and move forward. And hopefully the lag will go away. But if you see that, oh, I think there's a bug in my code, you can go fix that code and redeploy your service. And then hopefully, because the same message will be processed again because it was not committed yet. And now, hopefully, the bug went away, and also the lag will go away because the messages will get processed faster now. Okay, and another very important Greyhound feature for us at Wix is context propagation. So we have a lot of incoming HTTP requests, like you saw, and our users have a lot of data in those HTTP headers. So consider the following sign-up use case where a visitor of a Wix site wants to sign up and be a member of that site. Okay, so what can we retrieve from the headers? We have what's the language of the user? What's the geography? Is this user already a member or not? Or is this the Wix site owner? All this information can be gathered and handled by the site members service for the sign-up request. And if it wants to produce the message to Kafka and then have other services consume and process this event, then we want to keep all these headers, HTTP headers and request context as part of the flow going around in all of my microservices. So Greyhound just serializes this information into the Kafka record headers, and then other services like contact service that manages a Wix user's contacts can then consume this message and get all of this request context information automatically and then use it. Maybe they want to store some of that information in the database. Okay, cool. So that was a little bit of a Greyhound. We'll also return to it later in the talk. And the third lesson I want to describe today is when you have such a big amount of developers and use cases to support, you really want to have as much self-service as possible. So the third lesson is have self-service tooling and documentation in place. So in the past, we used to get a lot of questions on our Slack channel like, is there a way to search for a specific Kafka message? Or I would like to increase the number of partitions to an existing topic. And that is something that our team that is in charge of developing infrastructure needed to support. So we decided to have as much tools and documentation in place. And in terms of tooling, of course, there's the Kafka CLI scripts that you can consume messages and configure topics. But for our users, our developers, it's really quite difficult to get acquainted with each time and remember what are the flags that they need to have, and they need to install these scripts on their local machine. So having a web-based GUI interface is probably better for our developers, and there are open source solutions out there like the Yahoo Kafka Manager, and also a commercial one like Confluent Control Center. And but we decided to create our own control plane because of our own special needs. So here is a quick peek at our back office control plane for Kafka. So the first view here is to configure topics. So you can view the current configuration for each of the data centers. And then you can specify, for instance, increase the amount of partitions for some or all of the data centers. So that's very handy for our developers. And a very important view as well is to have live stream where you can specify the topic, data center, and from each time you want to get messages streamed to the view. And then you click play, you get messages streamed. And when you click on a message, you can see for a start which service produced the message, which services consumed it at which times. And you can also, of course, see the payload of the message with the nice formatting where you can copy parts of it if you need to. And also, of course, the headers that are the record that can help you debug the production error, maybe if there is one. And another very important view for our developers is the key value stores view. So with Kafka, you don't only have to use it as a messaging platform, it can also be used as storage, where there's the topics that are described as compacted topics, where the last value for each key of the record is kept. So you can think about it as a key value store. So here we have a view where our developers can actually view the current key values and maybe understand what's going on in production at the moment. Okay, so that was a quick peek at our back office for Kafka. And let's talk about documentation. So there is questions like, how do you investigate this lag, right? That's the big production issue with Kafka, growing lags. And questions about how to use Greyhound. I want to add retries on errors. So we created a very extensive GitHub README because developers are used to GitHub for getting information. We also add a lot of Q&A style data for our internal Stack Overflow site. And also on our channel, we have a Slack bot that answers questions without us needing to be present. So here's a look at the beginning of our Greyhound README and the Q&A style questions about how to investigate Kafka consumer lags. And we have our TrueBot here that tries to answer people's question from earlier questions on Slack or from Stack Overflow and other resources. And another very important topic about self-service is self-discovery of topics and message structure. When you have so many microservices with so many topics, you really need this to happen self-service. You can't have some team always needing to get this information out by getting questions from other teams. So for that, we developed an API viewing site where we get all the messages of structure defined in protobuf for our platformized services that are widely used. And they are then published to the internal API site using Swagger. And then the developers can view all of the gRPC requests and all of the Kafka events. And everything revolves around the protobuf schema. Of course, another very popular schema is the Avro one. And you can also use the schema registry from Confluent and then get not only viewing of the current schemas, but also the ability to manage versions of schemas. So that's a very good benefit of using the schema registry. But this is really helpful for our developer velocity. Okay, the fourth lesson for this talk is that monitoring in a completely distributed and asynchronous event style system is less trivial than your standard request reply in a synchronous manner. So for that, we really need to have as many metrics available for our developers as possible. So Greyhound has metrics built in that it makes exposed for the Prometheus matrix server on the producer side, the consumer side, and then we have automatic dashboards on Grafana for each service. It has a lot of interesting information. For instance, what's the currently longest running handler that the developer code provided that is currently getting stuck? So that can really help with investigations on the production layer. And also, if the lag is building up, you get automatic alerts sent as a developer to the email and to Slack. So here we can see, for example, an alert that incoming to Slack, and developer acknowledged this in less than a minute. So that's cool. And they need to check why did they have a slow handler specifically stuck on some message. Cool. So the fifth lesson for this talk is about proactive broker maintenance. So remember, at Wix, we have a lot of traffic and a lot of metadata, a lot of topics and partitions. And there's Apache Kafka blog post on the optimal amount of partitions, which is 4,000 for each broker, and then each cluster to have up to 200,000 partitions. So we took this into account and kept only adding brokers when needing and splitting clusters to smaller clusters in order to make sure that the broker is healthy and not getting stuck. Especially restarts can be quite long when you have so much metadata. And delete unused topics when you don't need them anymore. This allows us to avoid hard failures and keep the clusters healthy. And we're migrating to Confluent Cloud really this quarter. So this will make this work of keep making sure the cluster is healthy, not on our hands, but going to Confluent, that they provide high availability. So we don't need to worry about keep scaling the clusters. And they're also doing a lot of work on improving the maximal sizes that they handle. So we're really excited about that. Okay, the sixth lesson is avoid using Kafka SDK directly in Node.js. So at the beginning, we had only Scala services with the Greyhound library, but then as Node.js services started cropping up, we knew that we were going to need to have an equivalent of Greyhound to the Node.js. So Node.js platform team created a Grey Node, which they based on some JavaScript Kafka library, but it really wasn't an optimal solution. It's a quite buggy library, and they needed to keep catching up to what we did in Greyhound. So this really wasn't optimal. So instead, we created a sidecar, a proxy as a proxy service for Greyhound, where the Node.js communicates with using gRPC. So this really helped us have new features in Greyhound easily be provided to Node.js services as well. There is the downside here of having bigger memory footprint. We have double the amount of containers now for each Node.js pod, and there also JVM takes up more memory than Node.js. So we're trying to reduce it and considering moving from a sidecar container to a daemon set solution. Okay, the seventh lesson, remember we have 8 lessons, is consume and project. So this is talking about how to deal with legacy monolithic code. So we have a Metasite service at Wix that is in charge of helping know a lot about what's going on our Wix websites. For instance, it has information like what's the site version, who's the site owner, or what apps are currently installed on the site. And that's really popular flow that's needed for all of our verticals, for instance, stores, restaurants, and a lot of other services. So the database became really clogged and loaded in high contention for read and write with more than 1 million requests per minute, because it stored all of the Metasite need in one object on the database. So the team decided that they're going to split some of the flow here, specifically the installed apps contexts. And they did that by first producing the entire Metasite object context into Kafka as an event, as a site updated event, which then allowed them to create a completely additional new service called a reverse lookup writer that consumes these events, but is only interested in the app's context events. So it filters unnecessary information and stores in the database only the app's context. So it kind of projects the information to what it needs and creates a materialized view that is highly optimized for the query needs of our services. And it also created an additional service that's read-only, that's called a reverse lookup reader, where the RPC requests come to this service only, which means that it's really easy to just scale up reading throughput and traffic. We can have it all around the world, and it can actually read from database read-only replication that is eventually consistent from the master database table to the read-only replications all around the world. And for the last lesson for this talk, lesson number 8, we know that Kafka messaging is event-driven. But is it only relevant for service-to-service communication? What about browser-to-server interactions? Can they be event-driven? But a user is waiting for a response, right? Wrong. We can have event-driven work with the browser by using Kafka and WebSockets. So together, they offer us a completely distributed and event-driven solution. If we consider the following use case of a long-running asynchronous business process, we can see here that the browser can request to do an import of contacts from Google and Microsoft to the Wix platform for the Wix user. And they can do it like with request reply and then poll for the status of the importing of contacts. Are you finished yet? Are you finished yet? Are you finished yet? And the service in charge will need to create a database with all the statuses and optimistic locking, etc. But instead of that, we can use a WebSocket service in order to have this event-driven. So we have the context job service that creates jobs. And once the browsers subscribe for notifications for the WebSocket service with a channel ID for getting notifications back, it will send import requests to this jobs creator service. And this jobs creator service then creates these job events to Kafka Broker. And then we can have a lot of services to actually consume these events and actually do the importing. Because of this decoupling, we can have a lot of them. But let's say we had just one service with a lot of instances that actually does the importing from Google. And once it completes the job, it just sends the notification back, publishes it to the WebSocket service with the channel ID of the browser that came along for the ride on the Kafka event. And then the WebSocket service will just notify the browser on that channel. So we have a seamless flow here that is completely distributed and decoupled, and you don't need to add any more database entries and do polling. So you save up on resources and be a lot more efficient also. So to summarize, what do you do when the traffic and metadata and amount of developers and use cases keeps growing? Well, at Wix, we created an entire ecosystem to support large-scale Kafka-related needs with tools, with self-service, libraries, infrastructure, everything that our developers need in order to have the best support they can, and also our production environment to have the best debugging and investigation capabilities and robustness, of course, as well. And I'm very happy to announce that Greyhound is actually open source and publicly available on this GitHub link. And it offers both Scala SDK and a Java SDK. And 0.1 version is out now, so you can go and check it out and see for yourself. So thank you very much. And I've put all the slides on SlideShare, so you can go to SlideShare and see the slides if you want to go back to some material. And also you can follow me on Medium and Twitter in order to get updates on what we're up to all around event-driven architecture, Kafka-related topics, and also Zio and functional programming as well. And you can check out the previous conferences, talks I gave on my website at natansil.com. So thanks again.